Hi guys, so this lesson is on percent error, which is something that you're going to use a lot, especially in your science classes when you guys do labs. Oftentimes you're asked to figure out how far off you were, and that's using percent error. So you can think about how if you were measuring something and it was supposed to be a big number, like if I was trying to guess how many people were going to come to our pep rally and I said, oh, it's going to be about 100 students, and then 101 showed up. Well, I was off by one student, but that was only 1% of what I guessed, right? And only like less than 1% of how many actually showed up. But if I'm doing something and maybe I'm holding like tutoring hours and I think that there's going to be 3 students that show up and 4 students actually came, well, I'm off by the same amount, which is 1, but really it's a larger percent. So it kind of is a bigger difference when I'm guessing. And so maybe in those cases, it doesn't matter how far off I am, but there's times when it really actually does matter how far off we are. So our objective today is that we can calculate percent error. So for our review question on an independent practice in Canvas, Omar earned a 75%. If he got 9 questions correct, how many were on the independent practice? So go ahead and pause this video and see if you can answer this question on your own. Okay, so you should have paused this video. The first thing I'm going to do is I always know I'm going to be using quantity equals percent times whole on just about every percent question we're going to be doing. So he earned a 75%. So that's going to be our percent. That one's always easy to get the percent sign next to it. He got 9 questions correct, but we don't know how many questions were on the whole thing. So this is our quantity. Our whole is what we don't know. So for my quantity, I know it's going to be 9. My percent is 75%. And my whole is what I don't know. So that's going to be my mystery number X. So if you couldn't get this far and you think you can solve it now, pause the video and see if you can solve this question now. Okay, so the first thing we need to do is change this 75% to a decimal. So I'm just going to rewrite this where 75% is a decimal. We should be getting very good at conversions right now. That's 0.75 times our X. So now we have just the one-step equation. Our goal is to get X by itself on one side and a number on the other. So because this is multiplying, I need to do the opposite, which is dividing. I want to get rid of the 0.75. So I'm going to divide by 0.75. If I make a change on one side, I need to make the same change to the other side. So I'm going to divide by 0.75 on this side too. When we have 0.75 divided by 0.75, that's going to go to 1. And 1 times X is going to just leave us with X on the right side of the equal sign. On the left side of the equal sign, we have 9 divided by 0.75. So we should be checking these on our calculator. We always use the Desmos one. So if we do 9 divided by 0.75, we get 12. And we really got to start thinking, does this make sense in context of the problem? And it does. If he got 9 right and there were 12 questions, that is a 75, and that's a number that makes sense. It's not like it's like 100 questions or like he got like 3 questions on the total test, because that wouldn't make sense if he got 9 right. So we can put this in a full sentence because we need to start getting better at writing our full sentences. So there were 12 questions on the independent practice. For our preview question, it says Miss Marnon is putting grades in the grade book and accidentally put Omar's grade in as an 80%. How far off is she? So this is just you just kind of looking at, well, how far off was she really? So pause the video and see what you think. So if I put it in as an 80% instead of a 75, I was off by 5%. So we could say she was off by, we'll say 5 points. Because really we're going to talk about percent compared to the whole. So if I put his grade in as an 80 instead of a 75, I was wrong. I wasn't correct. I was off by just a little bit. So let's kind of get into some notes with some vocabulary here. So we're going to talk about absolute error and percent error. So there's two types of error today. So absolute error is just a fancy way of saying the absolute value of the difference between an exact value and an estimated value. So let's fill that in. So it's the absolute value of the difference. And when we say difference, we mean subtraction. Oh, it's not going to let me type there now for some reason. So we will just draw it out. So the absolute value of the difference between an exact value and an estimated value. So all we're saying is that we're going to do the absolute value of the actual minus the estimated. So in the case with me putting in Omar's question incorrectly, we could do the actual, which was 75, minus my estimated, or the one I messed up, the 80. But we want the absolute value of that. So 75 minus 80 is -5. And when we take that absolute value, it's just 5. So my absolute error was I was off by 5. Percent error is a little bit different because it's going to give us in kind of context. So percent error is the percent, the absolute error is away from the exact value. So how we're going to do this is we're going to do the absolute error, and then we're going to have to divide by the actual. So what this formula looks like is it's going to be the absolute value of the actual value minus the estimated. So the straight lines mean absolute value divided by the actual. This will give us a decimal. We know to go to a percent, we need to multiply by 100. So in the case of my guessing and putting in Omar's grade incorrectly, I would have to do the absolute value of the actual, which was a 75, minus what I guessed, which was the 80, divided by the actual, which was 75, and then times 100 in order to get it to a percent. So we can do some of this out by hand because we know the absolute value of 75 minus 80. This is -5. Absolute value of that is just going to be, so we have 5 over 75 times 100. So let's type that on our calculator. We have 5 divided by 75, and we need to multiply that by 100 to get a percent. So I was off by 6.6 repeating percent. And we show that the 6 repeats by putting the line on top. Percent. So if you wanted to, you could put in this whole thing as we wrote out the equation. Here's the absolute value button. So in the absolute value, you could have done 75 minus 80. Gone outside the absolute value signs, divided it by the 75, and then gone over to the side and multiplied by 100. You can also do those on the TI-34s that we have at school, but getting to absolute value is a little trickier. You have to hit the math button and then pick where it says ABS usually. So this is how we can type it. We can type it just into Desmos anytime we need to, or we can do it step by hand. As long as we are showing our work. If we type it in the calculator, it needs to be on our paper. So let's do some notes. So exercise 1, Keandra is measuring the length of a board she is using to make a birdhouse. She misreads the ruler and reads the length of the board as 23 inches. How bad of a job do you think Keandra's done? Why might you need to know the actual length to decide how bad her measurement was? So this one I kind of want you to think about and put in your own words. So pause the video and think about this question. How bad do you think she is? Why do you think we might need to know the actual length to see how bad she is? Okay, so we can't really tell how bad of a job she's done. So we can say we can't tell how far off her measurement is, right? We don't have anything to compare it to. But here's the thing, if it was 23¼ inches, she was pretty close. But if it was really 50 inches, she was really, really far. So it's going to depend on how long it really was. So we can kind of phrase that however we want. So we can say, if it was 23¼ she would be close. But if it was a bigger number or a smaller number, I'll say a further number because it's just going to be further from it, like 50, she would be really far. So depending on what that actual is going to depend on how far off she is, right? Because if she's pretty close, it's not bad. But if she's really far off, it's not really great. So now they're saying, okay, if the real length is 20 inches, how many inches was Keandra's measurement off by? So this one is asking for the absolute error. So how far off was she really? Well, she measured it to be 23, but it's really 20. So our absolute error is the actual minus the estimated. So the actual is 20 minus the estimated, which is 23. So 20 minus 23, or 20 plus negative 23, is going to be -3. But we still want the absolute value of that. So how far away it is from 0, which is just 3. So how many inches was she off? She was off by 3 inches. Part C, what percent of the actual length does your answer in part B represent? So now we want percent error. Let's change colors here. So this question is asking for the percent error. So we know it's going to be the absolute error on top of our fraction, right? The actual minus the estimated divided by the actual, and then we're going to multiply it by 100 in order to get it to be that percent number instead of a decimal. So let's just practice typing this into our calculator exactly as we see it, so we get comfortable with the calculator. So why don't you pause this video and try typing this into Desmos yourself. Okay, so let's do it now together. Hopefully you get the same answer as me, and if not, let's go back and check and see maybe what we typed in wrong. So we have the absolute value of 20 minus 23, all divided by 20, and then this whole thing times 100. So when we type it in, it should look like this, and I got the answer 15. So it's 15%. So her error, or her percent error, was 15%. So she was off by 15%. So that's kind of big, but it's not too bad. So let's just say she was off by 15%. So exercise 2. A table of 3 students' measurements of a 15-inch screen laptop is shown below. So part A says complete the table by determining each student's absolute error. So we can take 2 seconds and we can all fill this in. So figure out what the absolute error is by subtracting from 15 and taking the absolute value. Okay, so hopefully you figured out how far away it is from 15 and you did all of these absolute errors. So let's fill this in. So Sam got 15 2/8 for the 15-inch laptop. She was off by 2/8, and you can leave it slashed like that, or if you wanted to make it look like a pretty fraction, just highlight it. Under drawing, there's the math button, and it will change it to a fraction for you. Jenny measured it to be 15 4/8, so she was off by 4/8. We also know that 4/8 is just a half and 1/8 is a quarter, but they kind of wrote this so we could all see this kind of the same, who was the furthest off. Hodon said 15 or 14 and 7/8. If you subtracted those out, you should have found that she was off by 1/8. So Hodon was really the closest. So now we want to find each student's percent error. So I'm just going to give myself a little more room because I know I write big. So we can kind of skip writing out the whole thing if we want to. We can go right to writing the absolute error divided by the actual, because we already know it. So for Sam, her absolute error was 2/8, and we need to divide that by the actual, which was 15, and then multiply by 100 to get it to be a percent. So on our Desmos calculator, we can type this in. So if she was off by 2/8, let's type in our fraction, 2/8, but this is all divided by 15, and then we need to multiply by 100, and I got 1.6 repeating. The 7 is just because our calculator can't show us forever, so it rounds it. So Sam's percent error is 1.6 repeating percent. So it means she was off by 1.6%. So pause the video, see if you can try Jenny's. Okay, so for Jenny, you should have gotten 4/8 divided by 15 times 100. So we can type this on our calculator. All we're going to do is we're going to type it in 4/8 divided by 15, and then times that whole thing by 100. And we get 3.3 repeating percent. So Jenny was off by 3 1/3%. For Hodon, she was off by 1/8. So pause the video, see if you can figure out what her percent error is. Okay, so for Hodon, you get 1/8 divided by the actual, which was 15, times 100 to change the percent or the decimal to a percent. So we're going to do 1/8 divided by 15, and then all times 100. She was off not even by a whole percent, by 0.83 repeating percent. And we're going to put the line just over the 3 because that's the part that repeats. So Hodon wasn't even off by 1 whole percent. She's off by just a little bit. So she really did measure closer. So for the last question that we're going to do together here. Ms. Torres expected 18 students to come to her after-school club meeting. Instead, 25 people attended the meeting. What is Ms. Torres's percent error? So we're going to do the same formula that we put in our vocabulary up here. The absolute value of the actual minus the estimated divided by the actual times 100. So let's get back to my pen here. So the absolute value, the actual was 25 minus her estimated, which was 18. That's all an absolute value, divided by the actual, which was the 25 that really came, times 100. So pause the video and practice typing this in your calculator. Okay, so we're going to hit this absolute value button. We are going to do the actual is 25. Oops, I'm not in the absolute value brackets. 25 minus 18. And you see how I'm going back and forth and double checking my numbers? That's what we need to be doing when we're typing, because I think sometimes we're just having mistypes in our calculator. Divided by 25, all times 100. I got 28%. So Ms. Torres was off by 28%. So it is important to note we can do this using quantity equals percent times whole. So I'm going to write this off to this side in this light blue. If you were going to do any percent errors using quantity equals percent times whole, the quantity is your absolute error. So how far off you were. And the whole is just going to be your original or your actual. That's how wholes always end up working, is there are original or our actual what it's supposed to be. So if you think I cannot remember this new equation, Miss Marnon, you can always go back to quantity equals percent times whole. So if I was going to do this the way with quantity equals percent times whole, I would have to first find the difference with what Miss Torres got. So between 25 and 18, she was off by 7. That would be our quantity. Our percent is the mystery we're trying to find, times our whole. It was supposed to be, or it ended up being 25. So we could then solve this by dividing by 25 on each side. And you might even see some similarities between what we wrote here and what we have here. When you do 7 divided by 25, you get 0.28. Which we know when we convert that to a percent is 28%. So if you can't remember this new equation, you can always go back to quantity equals percent times whole. We learned it because it relates to every single percent question. So for this case, our quantity would be our absolute error, how far off you were. And you find that by subtracting. And then our whole is going to be our original value. And then we can solve for X and convert it to a percent. Sometimes it's easier though when they have something pre-made, if we do remember it, that we can just type it all in one step in our calculator. But if it is too hard for you to remember, we can always go back to quantity equals percent times whole. So when you're done with your notes, we have some practice. You don't need to do all of them. You only need to pick 2. Then you have your exit ticket. And these are all kind of situations that could happen in one of your classes. So you can see where percent error would come up in real life. When you're done with your 2 practice problems and your exit ticket, you're going to go into Canvas and you're going to complete independent practice 21. And there's going to be some questions about percents that we've already done. And there's also going to be some questions on percent error. Make sure that you do have your notes open. You can always come back and look at your notes while you are doing those independent practices.